Okay, let's continue with this since the last video cut me off. But so I'm gonna go over this one more time. My intervals were negative infinity 0, 0, 1, 1, 3, 3 infinity, as you can see from this number line, where 0, 1, and 3 were my critical points. So we always list the critical points and then partition off the number line based on those. Then I picked a test point in each of these. So in the first interval, I picked negative 1, anything to the left of 0. Between 0 and 1, I picked 1/2. 1 and 3, I picked 2. 3 to infinity, I picked 4. Now we're going to take these points and we're going to plug them into the original f prime of x. Not the simplified one, but the original one. And you can use like Desmos or a calculator to do this, and these are the values we get. So what we can see is in the first interval, where our test point was negative 1, we have a negative sign, so the function is decreasing. The second test point, the derivative had a negative sign, which means the function is decreasing. And where is that coming from? Remember this slide over here? Go back a little bit. This slide, if the derivative is greater than 0, then it's increasing. If it's less than 0, it's decreasing. So that's where we're getting these from. So because we're looking at the first derivative and its sign, negative sign means decreasing, decreasing, positive sign means increasing, and again, we have decreasing. Okay? So when we list out the intervals of increasing and decreasing, it's increasing between 1 and 3, and it's decreasing between negative infinity and 1. Now, why don't I put 0? Because it doesn't stop at 0, it keeps decreasing until it goes to 1. We're not changing from decreasing to increasing, so I can just say from negative infinity to 1, it's decreasing, and then also from 3 to infinity, it's decreasing according to our chart. Now, what could that look like? So here's one possible drawing for this. So if I just sketch a possible drawing, it's going to look like this. So from negative infinity until x equals to 0, so this is negative infinity until we hit 0, it's decreasing. But then from 0 to 1, it still keeps decreasing. It might like have like a little turning, but at the, overall, it's still going to be decreasing. So what we have is a critical, a turning point here. It doesn't turn at 0 because from 0, it keeps all the way going to 1. And at 1 is where it turns from decreasing to increasing. So remember that our local max and our local mins, they can only happen at turning points. So the second part of it says identify where each of these numbers is a local max or local min. Because we go from decreasing to increasing, 1 is going to be a local min. We're going from decreasing to increasing, not 0, because at 0 we keep going, we keep decreasing. Only when we go from decreasing to increasing, which is at 1, do we have a local min. And at 3, we go from increasing to decreasing, so we have a local max. So 1 is a local min, and 3 is a local max. And of course, we're talking here about the x values. All right, so make sure this is all copied down, but also, most importantly, come to class prepared with some questions that I can answer for you. Okay, graphically, here's what it looks like. So as you can see, the function, it keeps going down until we hit 0, and at 0, it still keeps decreasing. And then at 1, it keeps increasing till 3, and then at 3, it starts decreasing again, which is exactly what we said. So graphically, we just verified that our answer is correct. Now, last thing we're going to talk about is absolute minima or absolute maxima. So the difference between local mins and local maxes, so like local mins are just these turning points. Now, absolute means that we have a closed interval. So these intervals, they just keep going to infinity. But for absolute, we're going to have a closed interval. So we're going to start the function at negative 1, end it at 5. In this case, we started at this point and then go to this point. So we have a closed interval. Now, the absolute minimum and maximum, there are two possibilities. The absolute minimum could be here at the endpoints. So in this case, the absolute min and the absolute max, they happen at the endpoints. But the absolute minimum, which is the lowest value, it could also happen at a critical point where the derivative is 0. Like in this case, this is our endpoint, but it's not the lowest point. The lowest point is going to be this one. That's going to be our absolute min. And then our absolute max is going to be this point here. So when we talk about absolute minimum and absolute maximum, it's the lowest or the highest point on a closed interval. Okay, so once again, the absolute minima or maxima are on a closed interval, which means we have a starting and ending point, no infinity. So they can happen at the endpoints of the interval or at the critical points within the interval. So when we test for absolute minimum or absolute maximum, we have to test the endpoints, and we also have to test the critical points within the interval. Let's take a look at an example. We have the function 6x squared minus 6x plus 1, and the closed interval is between 0 and 8. So our endpoints are going to be 0 and 8. But we still need to know, do we have a critical point between 0 and 8? So what I'm going to do is, to find a critical point, I'm going to set the first derivative, which is 12x minus 6, equal to 0. So remember, critical points we find by setting the derivative equal to 0 or where it's undefined. But so far, it's always been equal to 0. And if I solve, I get x equals to 1/2. Now we have to make sure that x equals to 1/2 is between this interval 0 to 8, because that's the only interval we're looking at. And it is, 1/2 is between 0 and 8. So the 3 points we have to test are going to be the two endpoints, 0 and 8, and then our critical point, which is 1/2. Okay, so I'm going to test f of 0, f of 8, those are my endpoints, and also f of 1/2, which is the critical point. And the reason I'm doing this is because the min or the max could either happen at the endpoints, like here, lowest point, highest point, but it could also happen at the critical point, like in this case, where this is the lowest point on the graph. So I test all three of them, and I just plug these values into the original function to get the outputs. So f of 0, I replace all the x's with 0, I get 1. F of 8, I replace all the x's with 8, I get 337. And f of 1/2, I replace all the x's with 1/2, and I get negative 0.5. And feel free to use a calculator for that. Absolute means the lowest and highest point in this interval. So our lowest point, our absolute minimum, is going to be here. This is the lowest point of the three. So this is going to be the absolute min. Our highest point is going to be this one, 337. That's the maximum value. This is going to be our absolute max. So the absolute max happens at x equals 8, and the value is 337. The absolute min happens at x equals to 1/2, and that absolute min is negative 0.5. So for absolute, find the critical point, make sure it's in the interval that you're given, and then plug in the endpoints and plug in the critical point, and find the lowest and the highest values. Those are your absolute mins and your absolute maxes. That's it for this section.